Hello, welcome back to the video lesson for 3.1. This is all about quadratic functions and their graphs. So the first that we want to look at is definition. Yours will say, what is a quadratic function? So a quadratic function is a function that has the highest term as a 2. And this one is ax squared plus bx plus c. So there's an x squared term, an x term, and a constant term. Okay. The domain of a quadratic function is the set of all real numbers. Anything can go in. So a very basic quadratic is this right here. This is our base quadratic function, y equals x squared. Anything added or subtracted or from that transformations are going to be based from this one. So let's look at that in Desmos. I want you to see what that looks like. This is our base function where the vertex, we're going to learn about that. Our very bottom point here is 0, 0. And it can be face up or face down. This one is face up. This one is face down. And then if you look at example 1, I want you to type in these two functions. So this is the first function. I'm going to turn on that graph. And you can see that it's been shifted to the right and shifted up. It looks like it's been shifted to the right 3 and shifted up 2. If you graph the second one separately, it's actually equal to the first one. So notice that they are the same. I'm going to go back to my paper for a moment. So if we complete the square here, that means we're going to add 9. And so if we add 9, oh, we're gonna just add 9 here. That means we have to subtract 9 to keep it balanced. Then this actually factors into x minus 3 squared, and this adds to make 1. So that's how we complete the square, and we actually get to this format. So we're going to learn about both formats. This is in our x squared plus bx plus c format. Then if you flip the page of the notes, there is the standard form. This is in the vertex format of the form here. And so what I showed you by completing the square, we just went from this way of writing it, ax squared plus bx plus c, into writing it like this, where it's called our standard form. The graph of a quadratic function is called a parabola. It makes that U shape. And the vertex is the point at which it's either the very minimum value on this graph here on the left, or the vertex here is the very maximum value. And the minimum and the maximum, the vertex either way, is if it's in this standard format, h is our x value of our vertex, and k is our y value of our vertex. You can also see that this a out here in front, this coefficient plays a big role, because if a is bigger than 0, we call it face up. And then your vertex is a minimum. When a is less than 0, so this is when a is greater than 0. When a is less than 0, it's face down like a sad face. And then in that case, the vertex is our maximum. So example 2 says, let's use transformations to graph this. So we're going to use transformations. I really want you to notice the things that are happening here. We have 3 things that are happening here. So the minus 2 means that we're shifted to the right 2. And then negative 1 means we're down 1. And then this 2 out here means that we are magnifying it by a factor of 2. So we're going to go from this graph, we're going to shift it right 2 and down 1. So it should go from here, 1, 2, 1, 2, and down 1. So it should be 1, 2, and down 1 is, and then it's going to be a little bit skinnier because of the factor of 2 being multiplied. And then our vertex is going to be at 2 and a -1. That's our H and K. And let's go back to our graph to see this. So I'm going to turn these off. There's our basic again, and here's our new one. So she shifted over 2 to the right, and then it shifted down 1. And the 2 just makes it see it's more like a V shape instead of a rounded shape on the red. And that's because we multiplied by 2 out in front. So let's look at example 3. It says, use the technique of completing the square we learned in chapter 2 to transform the equation into the vertex form. And let me go back to my paper here. So we are going to use completing the square here to do that. So I'm going to factor out a 3 from this, so 3x squared minus 4, and then we've got our plus 7 out here. Oh, that's 4x. And so I've got 3, and then I'm going to take half of 4 and square it. So it's going to be x squared minus 4x, and then I'm adding 4. And really, I'm adding 12 because of the 3 out here. So I'm adding 12, so I've got plus 7 subtracting 12. Because I have to offset the plus 12 that I'm adding, so I have to subtract 12. So this means I have 3, and then x minus 2, the quantity squared, minus 5. So this should be my new equation of f of x in the format. And that means my vertex should be at 2 and a -5. So let's graph the equation that I gave you in the ax squared plus bx plus c format, and then let's see if it comes up and gives us a vertex at 2, -5. So y equals 3x squared minus 12x plus 7. And then there is our vertex down. We can see that on our graph at the bottom, it's 2 and -5. Just like we thought. So lots of new pieces and parts that we're learning about our parabola here. So I mentioned the vertex of our parabola we can use completing the square to go from this ax squared plus bx plus c format into the vertex format. We can also just go from our regular equation and use a, b, and c to find the vertex. So the h coordinate of our vertex is equal to a -b over 2a. And then our k is equal to c minus b squared over 4a. Or we could think of it as, once you find your h, you can just put the h into your function and get the y. And then our axis of symmetry, which is the line of which, if you were to draw it through the vertical through the parabola, is where exactly half is on the left and half is on the right. And that happens at the x coordinate of your vertex, -b over 2a. Notice they're the same, -b over 2a. So example 4 says, let's find the vertex. So a is equal to a -5, b is a -10, and c is equal to 1. So h on the vertex is equal to negative b over 2a. So the opposite of a negative 10 over 2 times a, which is a negative 5. So this will be positive 10 over a negative 10 is a negative 1. And then k is equal to the function evaluated at h, which is k, which is f of a negative 1. And so I'm putting a negative 1 into the function, a negative 5 times a negative 1 squared minus 10 times a negative 1 plus 1. So this is a negative 5 plus 10 plus 1 is 6. So my vertex is at negative 1, 6. And my axis of symmetry is always at the x, it's the line of the x value in the vertex. And I want you to always be able to see that you can see all of these things in your graphs as well. So if you type y equals and put the equation in there, negative 5x squared minus 1x plus 1. I'm going to turn off my original. I'm going to go up and click on, and there is our vertex, just exactly what we found, a negative 1, 6. Okay, so finding the real zeros of the function means we're setting the function equal to 0 and solving for x. Before you start, you can figure out how many, if any, real zeros there are by using the discriminant. The discriminant is b squared minus 4ac. If b squared minus 4ac is less than 0, if it's less than 0, there are no real zeros. If it's equal to 0, there is one real zero, and it will look like this, where it just touches the x-axis, either coming down or coming up. And if it's greater than 0, then there are two real zeros, where we can see it actually cross the x-axis. So example 5 says, use the discriminant to decide how many, if any, these quadratic functions have. So we need to find our a, b, and our c for each of these. Go ahead and take a minute to do that. And a is a negative 1, b is 1, and c is 3. And so b squared minus 4ac is equal to 1 squared minus 4 times a negative 1 times 3, which is 1 plus 12 or 13. And so it's greater than 0, so there's going to be two real zeros. Okay, the next one, a is 3, b is a negative 4, and c is 4. So b squared minus 4ac is a negative 4 squared minus 4 times 3 times c, which is 4. So that's 16 minus 48. That is a negative 32, and that's 0, less than 0, so there's no real zeros. And then C, we have A is a negative 1, B is 4, and C is a negative 4. B squared minus 4AC. So 4 squared minus 4 times a negative 1 times a negative 4. And so this equals 16 minus 16, or 0. So that tells us that there's one real zero. And we're going to learn how to find them all in this chapter. Isn't that exciting? Okay. There are a number of ways you can accomplish finding these. And one is by factoring. And then setting those factors equal to 0, or you can use a quadratic formula. And the quadratic formula is the opposite of b plus or minus the square root of that discriminant over 2a. So it says find the x-intercepts for this function here. So I'm going to factor 2x and x because I like to factor. I don't mind factoring. If you don't like factoring, you can use the quadratic formula. So I've got, they multiply to make a negative 4. I don't want that. Oh yeah, so I need these two to multiply to make a negative 2, and they do. This makes a positive 2x squared. And my outsides make a negative 4x, and my insides make a positive 1x. So that gives me a negative 3x. So that's one way. So I can set 2x plus 1 equal to 0 and solve for x equals a negative 1/2. And then I can set x minus 2 equal to 0 and x equals 2. So those are my two real zeros. Or I can use the quadratic equation, which says my x-intercepts are equal to the opposite of b, and mine is a negative 3, plus or minus the square root of b squared minus 4 times a times c, all over 2a. So this would be 3 plus or minus the square root of 9 plus 16 over 4. So 3 plus or minus the square root of 25 over 4. And we know the square root of 25 is 5. So we have 3 plus or minus 5 over 4. So I have to do it both a plus and a minus. So the plus would be 3 plus 5 over 4 is 2. And that matches this 2. And the other one is 3 minus 5 over 4 is a negative 1/2. And that matches this one. So example 6 says, find the x-intercepts for the function. So let's go ahead and find them. I'm going to use a quadratic equation again. So a negative 3 is a, b is 6, and c is a negative 2. So the opposite of b plus or minus b squared minus 4 times a times c, all over 2a. So we have a negative 6 plus or minus the square root of 36. Negative, negative, negative is subtracting 24 all over a negative 6. So a negative 6 plus or minus the square root of 12 over a negative 6. And square root of 12 could be the square root of 4 times the square root of 3. So it's really 2 times the square root of 3. So this x-intercepts are negative 6 plus or minus 2 times the square root of 3 over a negative 6. And we could simplify that into x equals a negative 1 over, or plus or minus the square root of 3 over a negative 3. Now, sometimes you're given the zeros, the x-intercepts, and you have to work backwards to an equation. So it says, find a possible expression for a quadratic function with the zeros at x equal 2 and x equal to negative 4. So if we think backwards here, where we took our factors, set them equal to 0 and solved, we're going to work backwards. We're going to take our x-intercepts that we know at x equal to 2 and x equal to a negative 4 and work backwards so they're set equal to 0. So if we subtract 2 from both sides, we get x minus 2 equals 0. If we add 4 to both sides, we get x plus 4 equals 0. And so if those are my two factors, I know that my quadratic equation is going to be my two factors multiplied together. Because that's what factors are by definition. They're numbers or letters or expressions being multiplied. And then I can multiply these, so I get x squared plus 4x minus 2x minus 8. And that simplifies to x squared plus 2x minus 8. And there is my possible expression. Now, there could be an A on here, but this is our basic expression that could work, but there could be an A that could change this a little bit. And that is all for lesson 3.1. Test me back for the next video.